Hi, so in this video I'm going to be explaining a little bit about parameter sharing in convolutional layers of a neural network compared to fully connected layers. So, and this is figure 9.5 from the deep learning book. Um, we're comparing two different layers. The top corresponds to what's happening in a convolutional layer. Bottom corresponds to what happens in the fully connected layer. And there's gray arrows that represent kind of like the other parameters, and black arrows represent the parameter of interest. So each one of these arrows represents a real number, about a weight that we need to learn to get predictions in the neural network. And so here we're focusing in the bottom. This is the case of one of the weights in a fully connected neural network, the one that's used as a part of predicting the unit S3 given X3. But we see that it's also there's connections from all of the other units to predict S3. But here we're just focusing on this one, and what we see is that all the other connections are gray, which means that all of these other ones are different real valued parameters. So in fact, there is no sharing between this weight and any of the other weights that are used to predict any of the other units. It's an independent parameter that needs to be learned. And so this has implications for statistical efficiency. So it means that basically you're going to have enough information in your training data to learn all of these separate weights in the fully connected layer. So in contrast, if we go to the top part of the figure here, we see that again we have this black arrow from X3 to S3 highlighted. Again, this is the input to the layer X3. Output the output is the next layer up, a unit in the next layer up, S3. And what we see is that here there's some other units which are some other weights represented by the zero here which are gray, and there's a bunch of other ones which are black. All of the units which are corresponding to these like straight up pointing arrows are black, which means that actually the weight here that's used to predict S3 given X3, it's the same weight that's used to predict S2 given X2, and it's the same weight that's used to predict X1 given S1. So actually, instead of having distinct parameters for each one of these different up arrows or these different weights in the layer, so here this is a situation here that we see in the fully connected case where we have distinct weights, right? We see these gray arrows which indicate that they're not the same as this black arrow which is highlighted. Up here, what we see is that all of these black arrows are highlighted, indicating that actually this is the same real valued weight that's used 5 times in this layer. So what it means is that it's less complicated to learn. So it can be statistically more efficient. That means we don't need as many training examples maybe to learn a model that gives good predictions. So yeah, again, to summarize, here at the bottom, this is the fully connected neural network where we don't have any parameter sharing. And here this is what's happening in the convolutional neural network where we have parameters that are shared. So this same black arrow weight is used in the definition of all of these next level weights. Thanks for listening.